So as we said, octet rule is having 8 electrons in the outmost shell, which means stability. Exception is helium, which is stable with 2 electrons, and the reason is 2 protons and 2 electrons. The only shell is first shell, and it is completed because first shell is s orbital can accommodate only 2 electrons. So having completed outer shell also makes happiness. This is the periodic table as we looked at before. And now I want to look at the cost of happiness. Guys, do you sometimes like to go out to eat because you want to be happy, otherwise you're tired of cooking at home? Is there a cost for that? Yes. So happiness has a cost. You want to go to a cruise to become happy? Yes, everybody loves that. Is there a cost for happiness? Yes. It's the same for the atoms. If atoms would like to be happy, they either have to lose electron. Is there a cost for losing electrons? Another word, do you remember that we said sodium would like to lose 1 electron? Sodium would like to lose 1 electron to become sodium ion, which is stable. Can I say this 1 electron which is going to be lost, is going to be removed from sodium, is attracted by the nucleus? Another word here. Let's see, 11 protons in the nucleus, and then first shell has 2 electrons in sodium, 8 electrons, and 1 electron. Can I say this 1 electron, which is on the third shell, is being pulled by 11 protons. 11 protons is pulling all these electrons. Although outer shell electrons are not as much pulled by inner shell electrons, however, they are being pulled by 11 protons. If these electrons are going to be removed from the atom of sodium, there is energy needed to pull out the electrons. So this is called ionization energy, amount of the energy needed to remove a valence electron. Why? Because protons are not going to let electrons go. So you have to break the interaction between the two. It's just the same thing as if you have 2 magnets, bring the opposite poles together, they stick together. You want to separate them, you have to use force. Otherwise, they stay together. So this force, which is needed, the force which is needed to break loose this 1 electron. This is electron pool between negative and positive. 1 negative charge and 11 positive charge. The force which is needed to take this electron out, that means break this attraction, is called ionization energy. How does ionization energy changes when we move from left of the periodic table to the right? Well, as we move from group 1A to 2A to 3A, we are going from left to right of the table. Do you see general pattern is increasing of the energy? Energy is increasing as we move left to right. the energy needed to remove one electron from one atom increases. So that means group 1A are easiest to remove electron from than group 2A. Group 3A is exception, but look at group 4A. Removing electron is going to need more energy. This is group 4A. Energy you need for group 2A and group 1A. The energy is increasing, going from 1A to 4A and 5A, 6A, 7A. So that's one energy involved in a chemical reaction. One energy which is involved in bond making. Now, what is the second part? We said in reaction of sodium with chlorine, chlorine gained electron, sodium lost electron. We already said for sodium to lose electron, we have to apply energy. What happens to chlorine? I'm sorry, what happens to chlorine when it gains one electron? Well, gaining electron is energy releasing. Why? This electron that you're adding to chlorine is going to be attracted by 17 protons of chlorine. Attraction is energy releasing. Repulsion is energy causing. Repulsion needs energy. Attraction is releasing energy. And the blue line is showing that some of the non-metals, like chlorine, is releasing energy when it gains electron. It's releasing this much energy, this much. So we call this electron affinity. What is electron affinity? Energy released when an atom gains an electron. Another word, there is positive and negative energy. The total cost depends. How much energy is used to remove the electron, how much energy is released to add the electron to chlorine. If you add these two energy values together, then you have the balance. The overall of this balance of reaction between sodium and chlorine, as I showed you at the beginning, there was a red hot flask. That means there is energy left over, so the energy would be released to surrounding. So actually, that's how we can calculate energy cost of a chemical reaction. If we are running a chemical reaction to make, let's say, a cosmetic product, we need to know, we need to calculate how much energy is needed for this reaction to go. That means we have to calculate how much fuel we should apply, how much heat we would produce for reaction to go. Or if we calculate and we see energy is released, a lot of heat is released, we need to calculate how much cooling water we should use, or how much air cooling we should do, so the whole reaction tower is not overheated and melted. So based on this give and take of energy, we can calculate the total energy released by a chemical reaction, and then we will use it in designing a plant to make sure the plant is safe, to make sure reactions absorb enough energy to actually do the reaction, or they release enough energy and we cool them off so reaction would go. Guys, when sodium metal with 11 electron lost 1 electron, it made sodium ion with +1 charge because it lost 1 electron. Yes? How about a metal which is in group 2A? See, sodium is in group 1A, and the charge of its ion is +1. What if I look at magnesium? If magnesium is reacting, it's in group 2A. It has to lose 2 electrons. Then magnesium will make Mg+2, not Mg+1. What if I look at aluminum, which is in group 3A? It's going to lose 3 electrons to have aluminum +3. So can I make this general rule about predicting the charge of the metals after they react? See, metals are electron donors. They lose electron. What charge do they have? They will have positive charge. What's the amount of the charge? It depends on the group number. Look at group number. Is it 1A? The charge is 1. Is it 2A? The charge is 2. The charge of their ion. Is it in group 3A? The charge is going to be +3. Does this make sense? Anybody?
Yeah.
Ask a question, please.
So
Anybody?
whatever negative charge the metal has, it will basically have the opposite positive charge.
Well, let's say whatever the group number of a metal, and these are we are talking about main group metal, which is group 1A, 2A, and 3A. Whatever the group number is, that would be the amount of positive charge. 1A +1 charge, 2A +2 charge, 3A +3 charge. Do I make sense?
Yes.
Thank you. Good job. Okay, let me go to the next slide and see if you grasp the concept. Go ahead, do this, please. Good job, guys. Excellent progress. I'm happy. You're listening and learning. You're a fast team of learners. Thank you.